Okay, so what I am saying, if a company has 3 branches, like this guys, same company has 1,000 branches as well, 100 number of branches as well, right? But for simplicity, let's suppose a company has 3 branches at different location. At different location, there are 3 branches. So, and in at each branch, guys, there are multiple buildings. Building 1, let's say building 2, like this, building 3, building 4, multiple buildings are there. So which type of network you are going to design at each branch? See, at each branch you need to design what? Network. No brother, LAN means implementing network in a single building. These are branch. Let's say this is branch 1, or I can say headquarter, or let's say I can say main office. Then here I have branch 2, branch 2, and this is my branch 3. And guys, at each branch, each branch we have multiple buildings. So let's say this is building 1, this is building 2. So inside the building 1 and building 2, you are going to design LAN, local area network, right? So one LAN in each building. And you know how to design a LAN network, which type of cable I need, which type of devices I need, yes or no? You need multiple switches, right, to connect multiple end devices. And end devices can be computer, laptop, server, IP phone, printer, IoT devices, yes or no? So you can connect these all devices together with the help of switch. That is what one LAN. And if you have multiple floor in the building, so you can add multiple switches, right? And later you are going to understand the stacking as well, how I can combine two switches together to increase the number of ports, because generally we are using 48 ports switches. So guys, if you have 100 number of users, so you can stack both switches together. Okay, but for now, you know the cabling, which type of cable I am going to use to connect end devices to switch, which type of cable I am going to use between switch to router. And you know, according to department, how many you can means determine how many switches are required there, how many cables are required there, what is the distance between switches for cable. And guys, now hope you are able to configure IP as well, means you can plan IP addressing, yes or no? So at each branch you have CAN network, campus area network, and you know the design of CAN, guys. Best design is multiple access layer switches are there, and these devices are connected with end devices, right? After that, here I can add distribution layer switch. At each branch, means in each campus we will have one design for CAN. So we have multiple types of design under CAN, campus area network, okay? But let's suppose, guys, in this scenario, in building 1 there are 3 departments. In building 1 there are 3 departments, D1, D2, D3, and you need to subnet. You need to subnet the main network, means you need to divide department. So you will configure VLAN, but before VLAN you need to subnet IPv4 network. So how you will subnet? Let's say this is the scenario. A company have 3 buildings with multiple departments, main office, three main office. Building 1 have one server room and two more department, IT and HR. Done, guys? So how you are going to design this network, this building network? Tell me in packet tracer. In packet tracer, inside building 1 you have three department. You can separate the department with the help of switch and VLAN, and let's suppose in each VLAN you need, in each VLAN means in each department you need around 200 IP addresses. You need around 200 IP addresses in each department. I have cleared this also. For now I am assuming the size of each department is same. Okay. Now now in the building 1 you have three departments. Let's say there are three floors, right? First floor is for server room, where you have placed all server, and your all branch users should be able to access that server room. We'll discuss about the configuration later. Only you need to understand IP configuration today, right? How we are going to implement private IP address and public IP address in the network. Guys, we have 32 bits IPv4 address, and to reduce the shortage of IPv4 address, we divide it into classes, so that for a small network you can use network from class C. If you have medium sized network, you can use network from class C, IP address from class B, and if you have large network, then you can use IP addresses from class C, just to reduce the wastage. Then to avoid the wastage, we come up with subnetting, right? With the help of subnetting, we are dividing large network into a smaller part. And now again from each classes we have divided IP address into two part. One is private and another one is public. Again, why? Because of shortage, so that public IP address can be reusable. If you are running also one company, I have also one company, and someone also have one company, these all three company can use same private network. So this is how we have reduced the shortage by dividing IPv4 address into two part, private and public. And private IP address can be reusable, means multiple organizations, companies, enterprises can use same private network. Hello? Yes, brother, voice is breaking. Is it okay now? Is it fine, guys, now? Better? Okay, so inside the building 1 you have three floors. At each floors you have some devices, and in each department you need around 200 IP addresses, and you have three buildings like this. So in packet tracer, how you will design the network? First of all, you have three departments, so three floor. Let's say this is floor 1, this is floor 2, and this is floor 3. At each floor you have one switch. Then guys, you have multiple AND devices, right? Maybe at one floor you have lots of servers. At each floor you can have one printer as well, IP phone, right? So these devices are AND devices, and like this you can have one access point as well, guys, at each floor. Access point for wireless connection. Let's say you have some devices which you can't connect through wire. So then you will set up one more device there, that is AP, access point. So for now, just assume access point is nothing but a device, a networking device who is connecting end devices without need of wire, wirelessly. They connect like switch connect end devices through wire, and access point is the device which connect end devices wirelessly without wire. So at each floor you can have access point as well, right? And then guys, these all devices are connected together, right? Which type of cable I am using here to connect these all devices to switch? Which type of cable I have used? Straight through. Okay, that is, wiring at each end of the cable. That is a straight through. These are Ethernet cable first, yes or no? And fast Ethernet. Fast Ethernet. That means each cable have 100 Mbps of bandwidth. Very good. Yes, brother. Okay. Now, how you are going to connect these all department together, brother? How you are going to connect these all department together? With the help of, first you are going to connect these all devices to layer 3 switch or router. But for better performance, you can add one more layer here between router and this switch and router. You can add one more layer, that is distribution layer. Guys, Cisco has one common architecture. What happened? What happened, sir? Someone who is recording the session, Santosh. Hello, Santosh. Or someone have, I'm getting echo from somewhere. Let me, yes, Santosh, from your side only. Please put yourself on mute. Yes, now it's fine, I think. So guys, for better performance, here I can add one more layer. Let's say two device or one device to connect these all switches together, or it can be your router as well, right? You can even connect these all devices to router directly. But for the real time in the production network like this, if you have 20 number of department or 20 numbers of subnets, so in that scenario, if you will add one extra layer here, it is going to enhance the performance of network. Now this is branch 1, and now which type of network it is? Is it branch 1, guys, or building 1? No, this is land. These all department is under one building, yes or no? So this is one building, means LAN, local area network. Even you can remove this layer 3 switch here, and you can connect these all access layer switches together, right? Let's say you don't want to add that switch, even you have option to connect these switches like this, these three switches like this, and now you can even connect one switch to router. That is also possible. This can be also a design, right? To reduce the cost, I've removed distribution layer switch. Or at each building, you can place one distribution layer switch for better performance. You have separated each building, guys, at distribution layer. And in this scenario, if you have 100 number of branches, they all are connected with single switch, and that single switch is connected with a router directly. Just think, if this switch will get goes down, all the devices will get disconnected. Yes or no? All the devices will get disconnected. We don't have any redundancy here. So that's why I think this design is not better, because let's say this is building 1, like this we have building 2, then building 3. They all are connected with this router. So this design is good. Even all users can access internet and all employees can access the resources on this server, but there is no redundancy, zero redundancy. If any device or any link will goes down, then entire branch will goes down. If router will fail or if this switch will fail, entire building will goes down. We don't have redundancy inside the building. Or if this switch will goes down, then only, guys, these two department will goes down. Yes or no? Or link between switch 0 and switch 1 will goes down. Then also only these two department will get disconnected. Even this department is connected with network. Santosh, I'm getting echo here, brother, from your side. Why you are unmuting yourself? Please concentrate now. Are you guys not getting me? What I am explaining, guys? Please tell me. Is class going good or not? Santosh, please keep yourself on mute, brother. Okay. So yeah, I'm going to remove this router, guys, and I'm going to add one, let's say, switch. Distribution layer switch here. And I can connect these switches like this also. Means there is interconnectivity between all access layer switches as well. And all switches are connected with distribution layer. To make it more better, what we can do, we can add one more distribution layer switch here, right? For redundancy at distribution layer also. Like, guys, see, if this is one building, then if this switch will goes down, then all users will get disconnected from network. But if I will add one more device here, and if I will connect all access layer switches to this device also, like this, then it is much better. Yes or no? Now we have full redundancy for these end devices, right? And as I have server room here, this design is good for this branch at least, because at this branch we have server room, and all remote branch users are going to access resources on this server. That is called network resources. Whatever application you are running on this server, guys, that is important. These employees or branch offices employees are working on this server only, on their application only, right? Don't worry, in real time you will have lots of server, right? With same configuration, guys, same service will be available on multiple server. On, let's say, 10 number of server, we have same service. So what I will do, I will use load balancing technology. Whenever we will receive traffic for this service, let's say HTTP service is running on these servers, and my all employees and outside users are accessing HTTP service. So one server cannot handle, right? So this load balancer is responsible to load balance the traffic, right? Means receive traffic from other branch or from the other building or from the internet and distribute it between these server. Send first request to this server, then this server, then this server, then this server, like this, right? So design is very important, very important. There should be redundancy, guys. You should have some free IP address as well in each subnet for scalability, so that if I want to increase some users, I can easily increase. Otherwise you have to add new subnet, or you have to change the subnetting plan. If you will change the subnetting plan, then you have to reconfigure IP addresses on each devices, guys. Like I have only 3 branch, see number of devices. If you have 1000 number of branches, then just assume how many devices are there. So is it possible to change IP addresses randomly? No. So you have to perform subnetting very carefully, and I am going to ask you how you will assign IP addresses to each department. I am not going to help you here, because if you know the subnetting, you can divide the network. So let's say this is my design for building 1. Yes. Okay. So in each department, guys, here you have 3 department, and in each department you need 200 IP addresses. And like this you have multiple building here, and multiple department as well, and multiple branches. So let's suppose your main subnet is, I'm going to give you the main subnet. The main subnet is, see, building 1 server room, building 2 sales and marketing department are there, in building 3 finance people are there. Okay, then branch 1, one building with multiple department. You can see we have multiple. Okay, let's suppose your main network is this one, 192.168.0.0/16, this one. This one is your main subnet. Yes. So hope this is clear that at each location, at each branch, you need 6 number of IP addresses, because you have 3 department, and each department has 200 users. Done? Clear? And guys, out of this 600, yes, yes, we can remove. Again, all devices have redundancy. You can even load balance as well, brother, between these switches, right? I can configure these switches in such a way so that it will forward one packet to this link and one packet to this link. Means for other department from this link, for other department from that link, right? No, no, by default it will follow one link. See, this link is up and this link is up, and this link is up. Only 3 links are up, rest are in blocking state, guys, means these are backup link. Whenever this active link will goes down, then it will come up. Getting my point, right? So now these devices are using only these three link. Actually, one protocol is running. We will discuss about that protocol later, how it working. Means how devices have put this link as a backup link and this link as a active link. We'll discuss those things. Okay. Yes, wireless router. No, your voice is very low, brother. Please speak loudly. This device is access point. Access point. And what is access point? Access point is used to connect end devices wirelessly. So let's suppose in this department I have some devices or guests which I can't connect through cable. So how I will connect these devices? With the help of this AP. That's it. That's why I have placed one AP here. Like this, you will have AP at each floor. Right? Like this, guys. I have another building. Like this, and here let's suppose I have only one distribution layer switch. See, I will send this description. According to this description, guys, you need to design one network, right, in packet tracer. And then you have to configure IP addresses. You have to identify the cables, which type of cable you are using. This is, let's say, building 2. Now I need to connect both building together. I need to connect both building together. So which type of network I will use? Which type of device I will use? See, this is my different network. Network in building 1 means CAN 1. Now this is my CAN 2. How I will connect two CAN together? With the help of router. So let's suppose I have one router here. Like this. Here also you will perform routing, so you need IP addresses between devices as well. But here, brother, you need only two IP addresses at each segment. So you will use what slash? What slash value you will use here? You need only two IP addresses. So slash 30. Very good. So we will decide IP addresses for these link later after doing subnetting for end users for department. So we'll always start subnetting from higher number of IP addresses to lower number of IP addresses. Let's say I need to divide a network into three parts. In department 1 I need 100 IP address, in department 2 I need 50, and in department 3 I need 30. Got it? So first we will perform subnetting to get 100 IP addresses, then I will perform subnetting to get 50 IP addresses, then I will perform subnetting to get 30 IP addresses. So first I will arrange it, right, in descending descending order like 100, 50 and 30, and after that I will perform submitting like this. Okay, so for these segments will perform submitting later. Now guys, this is what one branch. How we can connect multiple branches together? I can connect this to internet, yes or no? So like this, suppose I have one more branch guys, not three. Suppose I have only two branch. Router, then I have here, let's say, two department. Wait, later on I can configure the device as well, so let me choose correct device. Okay, like this. Yeah, go ahead. First and switch, second switch means? No, just you can assume that access point is placed at each switch. There is no difference. Difference is in term of configuration. Configuration of this switch is going to be different from this switch. That's it. And guys, you need 200 IP addresses in one department. Now tell me the subnetting. This is two branch offices. That's it. And both branches are connected through, let's say, internet. And I will tell you about the public IP address. Means IP address between your edge router, means this router and this router, and internet. Don't worry about the public IP address. Tell me the private IP addresses here. The main subnet is 192.168.0.0/16. I think you have enough amount of IP addresses. Tell me the network ID for first department guys, for this department, then this department, then this department. Or what is the network ID for this building, what is the network ID for this building, what is the network ID of this building. Please find. We'll do this configuration guys day by day, configuration in this network. When we will discuss protocol, we will implement protocol as well. By the way, I will create one another diagram. This is not good. But for now, tell me the IP addressing. Your main network is 192.168.0.0/16. Here you need 200 IP addresses. Right, here also you need 200 IP addresses. And here also you need 200 IP addresses. Like this, you need 200 IP addresses in each building. Yes. That means in this building you need how many IP addresses guys? Around 600. So how you are going to divide it? Let's say if you need to divide this network into two parts, and in one part there should be 600 IP addresses. What subnet mask you are going to use? How you will find? You will use which formula? 2 power h minus 2 should be greater than or equal to 600 for one building. right? Like this I can determine for department as well, but first I am dividing it on the basis of building, and before dividing it on the basis of building, guys, please divide it on the basis of branch. So in one branch, how many IP addresses are required? Around how many IP addresses? 600 here, 1200, right? Here also let's say you need 1200 IP address. So 2 to the power h minus 2 should be greater than or equal to 12. Then tell me what should be the value of h? 8, no 8, not. H is 8, that means you have 1024 IP addresses, not 255 IP addresses only. If H is 10, then how many IP addresses, guys, you have? So H should be what? 11. H should be H should be 11. So H is 11. If H is 11, then what will be network bits? N is what? Out of 32 bits IP address, 11 bits are host bit. What? 21. So if slash is 21, then what will be subnet mask? How many bits are on in third octet? 240. 248, guys. So block size? Block size? 8. Yes or no? So my first network is 192.168.0.0 slash 21, and my second network is 192.168.8.0 slash 21. This is for branch 1, this is for branch 2. Yes or no? Right, guys? Is it clear to all? Yes. Just wait, brother. See the issue as well. This is network ID for this branch. For this branch 192.168.8.0 slash 21 is the network ID for second branch. Now in branch 1, how many building you have? 2 building. So can you divide this network into 2 part? How? Yes. You have 3 department, by the way. 3. So 2 to the power h minus 2 should be greater than or equal to 600. Now what will be h? H should be 9. If h is 9, then n is going to be what? 512 कहाँ? Okay, h should be 10. Sorry, h should be 10. So n will be 22. So subnet mask will be 255.255. 250, 252 dot 0. So block size 4. So first network 192.168.0.0 slash 22 na, then 192.168.4.0 slash 22 for second building. This is for first building, this is for second building. For third building 192.168.8.0 slash 24. And guys, for fourth building for fourth department 22. Yes, 12.0 slash 24. Now how you are going to divide each subnet? On the basis of department. 22, 22. Sorry, it's my mistake. Right? So now your main network is for building 192.168.0.0 slash 22 for building 1. So how many valid IP addresses are there, guys? How many valid IP addresses are there? Valid IP address means 2 to the power h minus 2. Network bits are 22, means hosts are 10. How many valid IP addresses are there in one network? 1022. And you need how many IP addresses? Okay, now again you need to divide it into three parts. Can you divide it again into three parts? Yes. We'll use same formula. Okay, so guys, this is your topology. This is not your topology. Your topology is this one. Here is the topology. Yes, according to this, you will design topology in packet tracer and you will configure IP addresses on all the devices. Make sure you will use correct link, correct Ethernet type, correct IP addresses. Okay, right, like in each department you can write down the network ID. In each building you can write down the network ID, right? And you will design network like this. Yes, this building 1, building 2, building 3. In building 3 you have only one department. Let's say in building 2 you have two department. In building 1 you have three department at one branch. Okay, and then you have this main subnet and you will do the IP addressing after doing submitting. Right, here is the example as well, guys. Like you can see, I have divided first into this main network into how many parts? See brother, how many bits I have borrowed? 4 na? Don't know what happened. Submitting should be clear to everyone. I have borrowed 2 bit, that means into 4 part. After that slash 20 for building. This is for branch. This is for building. Then with slash 24. How many IP addresses are there? 254. Valid IP addresses are 254. Yes or no? For building 2 again I have this network and again I have divided into a smaller part. So this is how we are using subnetting in real time. Clear guys to all? Is it clear to all? Now tell me, you have three department. In department 1 you need 100 number of IP addresses. Here you need, let's say, 50 IP addresses. And here you need, let's say, 10 IP addresses. How you will do it? Tell me the network ID of each. Your main network is 192.168.10.0/24. Is it sufficient for these all department? Yes or no? Sufficient? Then tell me the network ID for department 1 and CIDR value for department 2 also, for department 3 also. Tell me very quickly. I need 100 number of IP addresses here. That means 2 to the power h minus 2 should be greater than or equal to 100. So h is going to be what? 7. So if h is 7, then n means 25. Very good. So 25 means subnet mask is 255.255.128. Right? So your network ID is going to be 192.168.10.0/25. Next network is 192.168.10.128.25. Yes or no? Subnet mask 255.255.255.128. Now from this network, how many valid IP addresses are there? 126. 126 valid, but you need only 50. So how you will perform subnetting here? Again 2 to the power h minus 2 should be greater than or equal to 50. Then h will be what? 6. That means n is 26. That means subnet mask is 255.255.255.192. Correct, guys? Network ID 192.168.10.128. Second network 192.168.10. Block size is, guys, what? 256 minus 192. 256 minus 192. Block size will be what? 64. So next network is going to be 64/25. So this network is perfect for department 2. How many valid IP addresses are there? 62. Correct, guys? So I can configure this in department 2. For department 3, I have this subnet. Then 192.168.10. Sorry, 128 plus 64 na here. Next network. Next network is going to be what? 10.192 plus 64. 192, correct? So here next network will be 192 slash value 25. So how many IP addresses are there? 62, but you need only 10 number of IP address. So how you will perform subnetting? Again 2 to the power h minus 2 should be greater than or equal to 10. So h will be what? H will be 4. कहाँ पे? हाँ यहाँ पे /26 होगा. सॉरी यार, ये /26 है. Sorry, this is /26 na brother. Yes, /26 here also. And here also. So then you have 64 IP addresses, correct? Here also you have /26. 192.168.10.192/26. Now here n will be what, guys? For 10 number of valid IP addresses, h should be 4. So n is going to be what? 28. So if n is 28, means if number of network bits is are 28, then subnet mask is going to be 255.255.255 dot. Hello. Subnet mask for 28. 2. Okay. So block size will be what? 16. So my next network is going to be 192.168.10.192 divided by 28. And this is perfect for department 3. Correct? So this is what VLSM. Why? Because see, length of each department is, or each network or each subnet is variable. So this is called VLSM, variable length subnet masking. So guys, we have two types of subnetting. Yes, brother, tell me. Your voice is very low, brother. Please speak loudly. Oh, you don't know this. Formula to find block size is 256 minus subnet mask of that octet where last one is present. So watch the subnetting video, brother. Yesterday video. Is it clear to all who have present in last class, guys? How I perform submitting for each department, everything, how to find block size, how I calculate number of host bit, everything. So brother, actually this is part of CCNA. You already, you know, completed CCNA training, and then you are asking block size. You didn't perform submitting questions, guys, brother? Or are you solving submitting without block size? Do you have any other formula? Block size, na? So how you are finding block size? What will be block size in department 1? Here slash value is 25. Then means block size is, or block size for this is 128. See guys, see brother, in last field you have one network bits and all are host bits. 7 host bits are there, correct? So that's the value is 128, and last one is present in 4th octet, right? 4th octet. So you need to subtract subnet mask of last octet where last one is present. So 256 minus 128. This is formula. So you will get 128. This is the block size. That means next network will start from 192.168.10.128. Block size tells from where your next network is starting. So this is how I find this network ID for 100 IP addresses, this network ID for 50 IP addresses, and this network ID for 10 number of IP addresses. Okay, so can I ask you one question? Okay, yesterday in the last class, guys, I think I had shared some question. Let me check. Yes, yes, brother, tell me the answer of these question. 10.0. Okay. 10.0. Is it true? Is it right? See, brother, your block size is 26, means 2 bits are on. That means block size will be 256 minus 192. That means 64. Means your first network is 10.0, second network is 10.64. Yes or no? And I am asking for the network ID of this IP address. So this IP address, correct? So this IP address belongs to this network, not this network. If I will ask you this IP 192.168.10. Let's say 70 slash 26. So this IP address belongs to which network? 10.64, not 10.0. Never say 10.0. Okay. Fifth network. Okay, let me do one thing. Let me share some submitting questions. Let me ask you some questions from the submitting. No problem. I will start with some model tomorrow. Let me discuss some submitting questions. Submitting Q&A. Yes. Yes, read the first question and tell me the answer, guys. Enter the last valid host on network that the host 10.86.86.62/30 is a part of. That means this is a valid IP address. It is asking you this IP address belongs to a network. So what will be the last IP address of that network? Getting my point? This is a valid IP address, so find the network ID and tell me the last IP address of that network. This is the question. How? Answer? Oh my god. Slash 27 means? Yes. 32 block size. That means first network is going to be 86.0, second network is going to be 86.64, then 86.64 plus 60, 32. Sorry, 32. 86.64, 86.96. So this IP address belongs to which network? 62. This network. So what will be last IP address? So next network is starting from 64. That means this network is ending on 86.63. So 62 is the last valid IP address. Getting my point? Yes or no? Tell me frankly. Okay. Then next question is this one. What are the maximum number of subnets and host per subnets for the 192.168.50.147.255.255.244? You need to find maximum number of subnet, means subnetwork, and host per subnet. How many valid users are there per network? So if guys subnet mask is, yes, how many bits here I have borrowed? How many bits I have borrowed here? 2 to 4 means slash 27, right? we have borrowed 5 bits. That means number of network is going to be what? I have borrowed not 5 bit, 3 bit, no brother. 24, this IP address belongs to class C, means default CIDR is 24. And I am using slash 23. That means I have borrowed 3 bits. If I have borrowed 3 bits, that means number of network is 8, 2 to the power 3. Option A is incorrect, option B is also incorrect, option D is also incorrect. Because we have only 8 subnet, right? And if network bits are 27, that means host, how many host bits are there? 5 are host bit. That means how many valid IP addresses are there? 2 to the power 5 minus 2, that means 30. See. So option C is the correct IP address, right? Guys, these are questions of CCNA 200301 exam paper from subnetting. Okay. These are questions of CCNA 200301 dump. I have separated exam questions from each topic. So these are questions from subnetting. See guys, what is the dotted decimal representation of slash 30 subnet mask? If you don't know subnetting, even few people are marking wrong answer to these type of questions as well. So slash 13 means I have borrowed how many bit? 8 plus 5 bits. Okay, so subnet mask will be 248. Yes. How many usable IP addresses can be assigned to host with slash 26? Slash 26 means 255.255.255.192. Correct? So how many usable IP addresses are there, guys? How many host bits are there? 6, right? So 2 to the power 6 minus 2. Can you guys solve this question by yourself if I will share the PDF? Or should I solve each question? You guys can solve it, right? Okay, so I will share this PDF. See, yeah, all are easy questions. No, no, no. For class C, see, you have reserved 24 for network bits. Nah, remember the IPv4 class. We have 24 bits, and out of that 24 bit also, I have reserved 3 bits. That will be always 110. Yes or no? No, 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 no. See, here we did subnetting after subnetting in the previous example. Like in this example also, right? First I divide this network into two part, then I perform subnetting on this. So this kind of thing can be called as supernetting. No, करेक्ट उसी के साथ प्ले कर सकते हैं. यू कैन प्ले ओनली विथ होस्ट बिट, एंड फॉर in class A, guys, you have 24 host bit. For class B, you have only 16 host bit, and for class C, you have only 8 host bits. So only you can use these bits to play with subnetting. You are not allowed to change network bits. Got it? On the basis of those bits, we already divide the IPv4 address into classes. Okay, and guys, again, from each class, now we have two types of IP address, private and public. Right? So from class A, your private IP address range is 10.0.0.02, 10.255.255.255. This is private IP range from class A. Rest all IP addresses are public IP addresses, guys. Right? So 2 to the power 24 private IP addresses are there in class A. Like this, we have range from class B also, from class C also. So in this network, you can see my edge router means this router and this router connected with internet router. So here I need to use public IP address, here I need to use public IP address, and on these interfaces, I will use private IP addresses, here I will use private IP addresses. So you are going to purchase public IP address from ISP. Again, public IP address, you know why we divide IP into private and public? To reduce the shortage. As I told you guys, we have shortage of IPv4 address. Still we have shortage. That's why we come up with IPv6. So to reduce the shortage, what we did, we divide IP address into part, private and public. And private is reusable, means other organization is going to use the private IP address. Why? Because public IP address is unique, is not reusable and routable on the internet. And guys, see, this complete organization will be known with the help of single public IP address. Now, how ISP is going to know your branch office one? With the help of public IP address, which is running over here on this interface. So inside your network, you have lots of IP addresses, right guys? Around 1200 IP addresses are there. But those all are what? Private IP addresses. And those all IP addresses are known with the help of single public IP address. So ISP will provide you one public IP address for this interface. And ISP will allow traffic from that IP address only on their interface. So from other IP address, you cannot send any data to internet router. It will block it. It will drop it. So whatever public IP address you are going to purchase from the ISP, only traffic from those public IP addresses are allowed on ISP router, on internet router. If you will send any kind of traffic with the help of private IP address, your ISP router is going to drop it. It will drop it because ISP only know the public IP address, right? And see how I have reduced the shortage. Now I can use my private IP address in other, means other company can use same private network in their building, their department, their branch, because ISP is the responsible to connect all around the world. And ISP knows each companies with the help of few public IP addresses. So let's suppose this is internet, and on the internet this is your company who is using 192.168.10.0/128 network, right? This is your private network. Your public network is, let's say, 1.1.1.0/30. That means dot 1 over here and dot 2 over here. So only dot 1 and 2 IP addresses are allowed on this interface. Rest traffic are blocked, denied. Now, ISP know you the entire private network with the help of this IP address, with the help of 1.1.1.1. Like this, guys, there is one on another company who is also using same network 192.168.10.0/128. Then this is not your company. This is not your company. Someone else. And this company also need public IP address. So let's say their public IP address is 1.1.2.1, and on this interface 1.1.2.2, like this. So can ISP make communication between this network and this network, guys? Yes. Yes, ISP can make communication between these two private network. How? Because ISP know this network with the help of this public IP address and this network with the help of this public IP address, and ISP router have route for both public network. So whatever network ISP is going to provide you, right? ISP will advertise that network in their internal routing table so that it will be distributed on all router on the internet, right? And because of this, as all public IP addresses are in the routing domain, in the internal routing, guys, all router have information about public IP address, right? This is how you are accessing internet, and internet can make communication between two private network. And see, both private sites or companies can use same network. It is not going to be like if someone will send traffic to internet for this company but ISP will forward it to this company. No, never. Never. Because every time, guys, whenever ISP is going to forward traffic in this network, in that scenario destination IP will be 1.1.1.1 every time. When internet is going to forward traffic to this company, whenever destination is going to be 1.1.2.1. And for all traffic in this company, destination is going to be this, and for all traffic coming in this company will have destination this. And your edge router is actually responsible to make it possible, because whenever any user from here send traffic to internet, means 8.8.8, let's say, so destination is 8.8.8, let's say source is 192.168.0.1/16, your end device will forward it to router. Now router is going to translate source IP address. It will make one table that I'm going to translate 192.168.0.1 into 1.1.1.1, right? So it have translated the source. So now new source is 1.1.1.1, and then destination 8.8.8.8, and after that it will forward to internet router. Now can internet router accept it? Yes, because this traffic is coming from purchased public IP address which is routable on the internet, right? So okay, traffic is coming from correct IP address, it will forward it to 8.8.8, and when 8.8.8 will generate reply, it will forward packet to internet router. Test source is going to be what that time 8.8.8.8, because 8.8.8 is generating reply, and destination is going to be what 1.1.1.1, because that device had received request from 1.1.1. So ISP router will forward it to router. Now router have already information in their table that whenever traffic will come with this IP address, I will translate into this IP address. So now router is going to again translate the public IP address, this time public to private. At the time of request, private to public. So in This way we reduce the shortage of IPv4 address guys, and this is why still we are able to use IPv4 addresses. Otherwise you have only 2 to the power 32 IP addresses. But you know, nowadays more than this, double of this, thrice of this private IP addresses are in use nowadays because of these technologies like NAT, subnetting, dividing IPv4 addresses into classes, then dividing it into private and public. Getting my point? This is the private network 10.0.0.0/24. Right? This is a private network I can use inside my network. But you know, guys, like me, like you, already there are more than 1,000 number of companies who are using this network. So this is just because of private and public concept, so that we can use private IP addresses again, reusable, make it reusable. All clear about IPv4 addressing? All clear? Anything about IPv4? Yeah, tell me, brother. Any doubt about IPv4 addressing? Hope this is clear. And why we divide it into multiple parts, like into classes, into private public, then subnetting, then VLSM. Now guys, try to understand one very important concept in networking. Let's suppose I have two computer, two computer only, connected with each other. PC1 or PCA and PCB. PC1 IP address is, or let's say PCA IP address is A, B. This is MAC address of PC1, PC2. IP address is, let's say, 10.0.0.1/24. Here IP address is, let's say, 10.0.0.2/24. I can use this IP address. Both are in same network or different network? Both are in same network, yes. Both IP address belongs to same network. If you will find the network ID of PC1 and PC2, you will get same network ID, right? Now let's suppose PCA want to send any kind of data to PCB, let's say one file, or just ICMP request message, any type of message. If PC1 want to send to PC2, how they can send? Let's say this is the data, actual data that PC1 want to send to PC2. How PC1 can send to? Let's suppose you have one letter and you want to send that letter to your family member or friend, right? You have write down the letter. How you can send this letter to your friend or to your family member? What need, guys? What is needed over here? Address. Without address I cannot send this letter. So how you will add address here? You will put this letter in one envelope, right? And on the envelope, guys, you are going to write source address and destination address, correct? Now only you can send this letter to your friend or family member to correct destination, we can say. Or now only you can hand over this letter to someone, maybe to postman. Without address, if you will hand over it to someone, right, no one can forward it to your friend, right? Because address is important. Like this, if computer A want to send, or PC1 want to send data to PC2, computer A have to add address with this actual data. Yes or no? Yes or no, guys? Yes. So who is going to add the address? Actually, by default, some protocols are running on your devices, guys. On your computer also, on Cisco switch also, on Cisco router also, on firewall also. By default, some protocols are enabled. Like you are able to use operating system. That means many software are installed there in your operating system. Yes or no? Like this, some protocols are running on devices by default, and those protocols are responsible to add addresses with actual data. So first thing, this data needs source IP and destination IP. So the protocol which is running on your device who is going to add source IP and destination IP is IP protocol, right? So if it is adding IPv4 address, that means IPv4 protocol is running, right? IPv4 protocol. What is the use of IPv4 protocol here? For now, IPv4 protocol is responsible to add source IP and destination IP with every data or with every information. Yes, clear? So IP protocol is going to add one extra header here, that is envelope. Envelope, it is putting actual data in the envelope, and on the envelope it is going to add source IP which is 10.0.0.1, and then destination IP which is going to be 10.0.0.2. Fine. IP protocol have added source IP and destination IP with data. Then guys, this actual information needs source MAC and destination MAC also. So Ethernet protocol is responsible to add source MAC and destination MAC here. A protocol is ARPA protocol. ARPA, ARP, A. ARPA protocol is responsible to add source MAC and destination MAC with actual data. So ARPA protocol is going to add source MAC. Here source MAC will be A. Then destination MAC. So this machine will check their ARP table. It will find what is the MAC address of 10.0.0.2. Let's say in the ARP table MAC address is not available. Then what ARPA protocol will do? ARPA protocol will call to which protocol, guys? ARP protocol. Remember, whenever a device need MAC address from IP address, it will call to ARP protocol. ARP stands for Address Resolution Protocol, right? Which is used to resolve MAC address from IP address. ARP is a protocol which is used to resolve MAC address from IP address. Like if this machine know destination IP is 10.2, but I don't know the destination MAC. So ARPA protocol is going to call ARP protocol. Hey ARP, please find the MAC address of 10.0.0.2. ARP protocol will generate a ARP request message where target IP address is going to be 10.0.0.2. That means who will generate reply? Who is using this IP address 10.0.0.2, and ARP protocol is going to broadcast it. It will forward packet to all the user in network. So when PC2 will receive the broadcast message, it will check, oh, target IP address is my IP address. That means someone is looking for my MAC address. Let me share my MAC address. It will generate ARP request and then send to PC1. Again, ARP protocol is going to update the ARP table. It will make one entry in the ARP table, right? And then it will inform to ARPA protocol, brother, I have resolved the MAC address. Then ARPA protocol is going to define destination MAC here. That is B. Done. Now PC1 can send this data to PC2. So PC1 is going to transmit it from the link, from this link. Now guys, suppose on PC number 2, we have different protocol, right? For adding IP addresses, I'm running IPv6 protocol, let's say, right? And for adding source MAC and destination MAC also, let's say I'm using another protocol, XYZ protocol. XYZ protocol, any other protocol. So when PC will receive it, PCB need to remove this extra information to check actual information, yes or no? See, when your friend will receive the letter, first of all your friend is going to remove the envelope, right? So see, in the complete packet, guys, my data is inside the header, right? Outer header is this one, outer envelope is this one, then this envelope, and then I have actual data. So first PC2 need to remove this information. So PCB is going to check destination MAC. Now see, on PCB which protocol will check destination MAC? ARPA protocol, yes or no? But here ARPA protocol is not running. So PC2 cannot understand this message, this packet, and PC2 is going to drop it. Now suppose, why protocol is different on PC2 and protocol is different on PC1? Because you know, PC1 is manufactured by different vendor company, that is Dell. PC1 is manufactured by Dell company and PC2 is manufactured by, let's say, HP company or IBM. HP, both are using different protocols. So guys, you tell me, can these two devices communicate with each other? No, never. Because the protocol, the process of communication is different, right? They'll have their own process of communication, their all protocol for communication, and HP has their own protocol for communication, own process for communication. These two devices cannot communicate like this. All vendor had their own, guys, operating system, their own process, their own protocols. That's why we come up with OSI model. So why we come up with more OSI model? To make communication possible between two different vendor devices. Now I am the organization, big organization, who is going to decide how two devices will communicate with each other. How two devices going to communicate with each other? I will decide. I will make one process. I will create lots of protocols. I will implement the protocols in operating system, right? And then I'm going to distribute this list of protocol or process to all vendor company. That brother, if you want to connect your device to internet, you have to follow only this process. You have to run only this protocol. Right, guys? So OSI is developed by one organization. May I know the name of organization? OSI is developed by which? Yes, tell me. Very good. And guys, that organization have designed one common process for communication. This is how two devices going to communicate. Before communication, we were using, computers for gaming, for maintaining database, for playing game. For those purposes, we were using computers. Later on, we started using computers in office for excels. Then we decided to make communication between them so that we can transfer data easily between two people with the help of device. So in starting day, all vendors started working on it to make communication possible between devices, between networking devices, and all have designed their own process, right? That was not common, guys. And as those was not common, different vendor devices was not able to communicate with each other. So that's why this organization have designed one model. In that model, they define each protocol process for communication, and they have distributed that blueprint. You can say OSI model is a blueprint distributed to all vendor devices to follow this step only. If you are going to manufacture one computer by any other method or by using any other protocol, let's say at layer 3 you are using different protocol, right, which is not part of, let's say, Windows 10, 12, 11, 9, 7, these operating system. If it is not part of these operating system, they cannot communicate. For the communication, guys, we have different process, different protocol which is running on devices. With the help of that only these devices are able to communicate with each other. And how it is common with the help of OSI model. So anyone can ask you why we come with some OSI model, guys. So you can say we come up with OSI model to make communication possible between different vendor devices. Now see, if both company Dell and HP is going to manufacture computer according to OSI model, then at both device same protocol will be running, like IPv4 protocol will be running there and ARPA protocol will be running there. Yes or no? IPv4 protocol for adding IPv4 and IPv6. ARPA protocol is for adding source MAC and destination MAC. Getting my point? Because both have designed their hardware according to OSI model. Getting my point, guys? So if someone will ask you what is OSI model, so guys tell me the answer. What is OSI model? Why OSI model is clear? To make communication between different vendor devices. Now what is OSI model? OSI model is a process which tells how data ought from a computer and how data enter in a computer, right? How PC1 is going to exit the data and how PC2 is going to receive the data. This is what OSI model, right? So while sending data, both means while sending data, PC1 is going to perform some task like adding source IP, destination IP, adding source MAC, destination MAC. This is what one kind of task. Every time whenever this PC need to send any kind of data to any machine, it have to perform these tasks, adding source IP, destination IP, source MAC, destination MAC. Like this we have port number as well, source port, destination port, and for each task one protocol is running, guys. One protocol is running which is responsible. Even nowadays IPv4 and IPv6 both protocols are running. If the machine need to encapsulate with IPv6, need to add IPv6 source and IP, it will add IPv6 addresses. We can have multiple protocols as well. So while sending data, it will perform some task. Task means adding some extra information, and adding some extra information is called encapsulation. Encapsulation means encapsulating something, right? Actual data, then I am encapsulating it in an envelope. This is what encapsulation, yes or no? So adding extra information with actual data is called encapsulation. And when receiver machine will receive it, see, receiver machine need what? This actual information only. This extra information is only to send the data to correct machine. That's it. This is the only need of these extra information to send it to correct machine. So whenever receiver machine will receive the data, first receiver machine need to remove these extra information. So removing extra information from actual data is known as decapsulation. Decapsulation. Okay guys. And see, while doing encapsulation or decapsulation, or you can say while sending data or while receiving data, whatever task these machines are going to perform, that is OSI model. And we divide these tasks into multiple parts. Why we divide anything? Again, to make it easy. So we divide the task into 7 parts to make it easy. That's it. Reason of dividing anything, reason of dividing large network into a smaller network by doing subnetting is just for easier management, for better performance, for better security. This is the reason why we are segmenting the network, why we are dividing large network into a smaller network. Dividing a book into chapters just to make it easy for the people who are going to read this book. So logic behind dividing anything is making it easy. That's it. So if task is complicated, I cannot teach you, because lots of things is going to happen when a PC will send traffic. When PC will exit traffic from their interface, lots of things will happen, right? So I cannot teach you those all things in a single box. So that's why we divide all the things into 7 part, just to make it easy. So why we come up with OSI model? We come up with OSI model to make communication possible between different vendor devices. OSI model is nothing but a process which tells how data will out and how data will in a computer. Whenever a computer sends data, it performs some task like adding source IP, destination IP, source MAC, destination MAC, source port, destination port, doing encryption. See, encryption is also important. Like your actual data is I love you, and you are sending this information to your girlfriend or your to boyfriend. What if someone will capture the link and if they can read the data, right? Or you are sending $500 to your friend. What if someone will capture your data and if they will change the destination? If they will change the destination, then $500 is going to be in another account, guys. Yes or no? If there is one attacker on link, let's say both PCs connected with internet, and PC A is sending $500 to PC B. What if someone will change the destination on internet? What if someone will read your data? So security is also important. Encryption is also important. So before sending the actual data, your sender machine need to encrypt the data also. So again, they need protocol for encryption. So lots of tasks are there. Getting my point? So we divide those all tasks into 7 part, into 7 layers, you can say. Layers. Each layer is going to perform some task on PC. And name of layers are, may I know the name of layers? 8 layers. First one is application layer. Presentation layer. Third, session layer. Then transport layer. Then no, network layer. Then data link layer. Then physical layer. Okay, so guys, physical layer is not layer 1, or application layer is layer 7. This is layer 7. Physical layer is not layer 7 or layer 1, and application layer is also not layer 1 or layer 7. While sending the data, let's say PC1 want to send some information to PC2. So PC1 is going to follow this sequence. Maybe first it will generate data at application layer, then presentation layer is there, so presentation layer will encrypt the data. Then we have session layer. Session layer is going to create one session. Then transport layer. Transport layer is responsible to add source port and destination port with actual data. Then network layer. Network layer is going to add source IP, destination IP. Then data link layer. Data link layer is going to add source MAC, destination MAC. And then physical layer. Physical layer is going to convert your signal, your data into bits. Convert your data into bits. Your data can travel in form of 0 1 only, in form of 0 1 only. So physical layer will convert it into bits. After that PC1 will transmit it from the link. But when PC2 will receive it, it will receive at which layer, guys? At physical layer. It will receive at physical layer, and it will goes from down to top, like physical layer to application layer. At physical layer, first it will again, PCB is going to again convert binary 0 1 into, yes, into frame. Then data link layer is going to remove source MAC and destination MAC. First it will check destination MAC. If it will match, then it will remove it. After that it will hand over to network layer. Then network layer is going to remove source IP, destination IP. Then it will hand over to transport layer. Transport layer is going to remove source MAC, destination MAC. Session layer. Session layer is going to create the session. Presentation layer. Presentation layer is going to decrypt the data, and then at application layer you will have actual data. You will have actual data, that is, let's say I love you, right? Or data can be, guys, anything. Apart from the data, we have lots of information, and this is what you need to learn in OSI Moodle and TCP/IP Moodle. Is it clear? So tomorrow, guys, I will start OSI Moodle. Now if anyone have question, please ask. Yes.